Hello everyone, welcome to Unit 1 of Integrated Big Data Solutions. In this session, we will learn the fundamentals of distributed computing. We will understand why distributed systems are needed, how they work, and where they are used in real world applications. Let's go. So, these are the key skills you are going to learn, you will get from ending of this semester, like big data storage, distributed processing tools, data streaming, NoSQL databases, end-to-end data pipeline development. So now we are going to see about why integrated big data solutions are needed for this industry. So here, let's look at a real industry problem. Starbucks stored customer information in different systems. Because these systems were not properly integrated, customers sometimes received offers for products they had already purchased. So, this shows the importance of proper data integration. Without proper data integration, the company like Starbucks will also create some problems to the customers without giving the proper information to their customers. They may lose customers easily. So next we are going to see another one examples like airline examples. So here reservation systems used by websites, travel agents and airport counters were not synchronized in real time. So this makes the passenger to be in a discomfort by getting allocated a single sheet for multiple persons. So this creates the issues without considering the distributed systems. So they are now are dependent to bring their distributed systems to solve this synchronization problem. So now think about voter ID record. For example, some more you have already know about some of your relations or your friends may have one or more than one voter ID with them. This is because still our country is in lack in getting some distributed systems in creating in the voter ID. So somehow they are getting fail again and again by implementing the distributed systems in this voter ID election commission. So next, why learn integrated big data solutions? Here, integrated big data solutions form the backbone of AI and data science. They enable us to process massive structured and unstructured data sets, integrate information from different sources, support real-time analytics, and provide high-quality data for machine learning applications. So, uh, so apart from distributed system, first we have to know about standalone system. The standalone system is none other is a system that works independently. All process, storage, and applications are executed on a single machine. Example: personal computers and laptops. So next, what is the disadvantages of standalone system? Standalone system have several limitations. They can't easily share resources, support collaborations, or provide remote access. Their storage and processing capacity are limited, and scaling requires purchasing more independent machines. So this diagram shows about the standalone system. You can see here many process will be standing in a queue. Then standalone systems can execute one after the one alone. It may takes time and it occupies more memory. So it's like a queue. The process should wait until it is before process it should be completed. So why cannot we already seen about why the standalone cannot do this. For example, we are going to see about the examples like So you should know about why the standalone computers fails. Their CPU and memory will be limited. Um, their response time will be very large, and it cannot easily handle the global demand, right? Without, for example, you can consider that one single person handling multiple tasks at a time, he may skip one or other or any important task like that. So this may create a pressure to that resource, and also he may fail to complete every task allocated to him. So distributed systems. So this is the need to go from standalone system to the distributed system. So the image shows that the multiple systems can connected over the switch, and each computer gives us many processes through switch to network, that many devices like servers, applications, database will be allocated. Each process will be allocated based on that many process will be done, and again given to the respective computers. So this may create a, yes, it may create some healthy environment, that every person, so every process cannot don't want to need to stand every time to get completed. That many processes will be distributed to the cloud, and many applications and services like virtual desktop and database applications will handle those processes and give back the result to these respective computers. So advantages will be the scalability, fault tolerance, performance, resource sharing, and flexibility. So you may see this real-time example, vesselfinder.com. You may see those yellow lines and pink color dots, green color dots, pink, green color arrow. These everything shows the vessels that they are traveling per day throughout the world in a sea. So every signal, every each arrow mark shows the individual system. So everything will be collected by a one website, and it will everything will be processed, and it will give the so one view of computer can one system can view this many computers work in a single window. So this is the how distributed system works in the vessel finder website. So you can see here, the AS, the boat will have an AS station. This will send an signal to the through internet to the distributed application layer. Here, the load balancer will balance those loads and transfer those process to each servers, and each servers will process and give the data to the distributed database layer. From those distributed layer, the content delivery applications will be worked. So based on the user view, the content will be displayed to their display. So these are the explanations we have already seen. This is another example where millions of users will see a cricket match or football match or hockey match through their phone from staying in home itself. So this is the another one example for distributed computer, where the videos will be stored in multiple servers. So if I am, for example, if I am viewing a video from example like Chennai, the servers will be located near Chennai. From the server, I will get the video streaming. So this is the another example for the any movie booking, ticket booking website. So for every booking website or any distribute system, we will have a load balancer, and those load balancer will distribute the process to the many servers and to distribute a database, and finally the end user will get the one screen output. So what will be the characteristics of distributed system? So distributed system has collection of autonomous computing elements. uh, Autonomous elements means these every system will act as an autonomous element. So collection of autonomous element will be the distributed system. Second characteristics will be appears as a single coherent system. So Maybe, yeah, back end of the user system will be have many collection of servers will be or back of the user's window, but output will be the single coherent system. The output of the user may think that only my system is getting the input, but back of that window, many servers will be helping to show one output in the user window. So design goals: resource sharing, openness, scalability, and distribution transparency. So types of distributed systems like are distributed computing systems, information system, and pervasive system. So these are all about the introduction about distributed computing system. In next class, we will see about message sharing and communication about in distributed computing system. Thank you.